Hi everyone, so my name is Amir Jerbi. I'm the CTO and co-founder of a company called J.H.A Security, based in Israel. So thank you for having the opportunity to speak here. And in this session, what we are going to do is a workshop. We are going to go over some of the open source tools that are related to Kubernetes. We're going to go over two open source tools. One of them is called kube-hunter, the second one is kube-bench, and the third one is something called microscanner. Microscanner is not open source, but it is a free tool also for Kubernetes. With show of hands, how many people here know what Kubernetes is? Good, so I don't need to explain Kubernetes. So let's start. So Kubernetes, as you probably know, has a lot of native capabilities, native security capabilities that come out of the box. But it doesn't have a very good, I would say, secure by default approach. What do I mean is that there are many ways to install Kubernetes. You can install it with some weak default configurations, and I will show you examples of that and what can be the impact of weak configurations. And you can tune and configure it to be very hardened and very secure. Right? This is what we all want to have. The nice thing is that a lot of capabilities, like I said, are already there out of the box, natively integrated, and you just need to know about them, and you just need to know how to tune them. So, for the reference of this talk, I've created a small Github project. You see the link there. Maybe take a picture or go into it. It has the presentation that I'm just now showing you, so everything is there. You don't need to to take screenshots because you can just use the presentation. And the README file has all of the references to the exercises that hopefully those of you with a laptop that have Kubernetes can try out, the things that I'm going to show you. If you don't have a laptop, don't worry, I will also do the black screen myself, so you will be able to see everything. So, let's start. The first thing I would like to talk about is configuring Kubernetes. Does someone has an idea here? Give me a number of how many different flavors of Kubernetes you think there are out there. 10? 100? Okay. So it's more, it's 150. I think 159 is the accurate, but it changes every day. And basically, Kubernetes is very similar to Linux, right? So you have upstream version, and you have then a lot of variations. People can fork from that, can create different deployment types, can create different settings, different configuration. The system itself, the platform itself is very flexible. And when people are talking about Kubernetes, usually they are talking about those components that you can see right now on screen. There is the API server. The API server is something that you send a command, start pod, stop pod, show me the list of pods. Everything is sent to the API server using RESTful API. The API server will either go to etcd, to its database, in order to retrieve the state of the cluster and returns results. And in some cases, it will also send it via scheduler to the nodes themselves. On each node, there is something called kubelet. It's a daemon that receives requests and then does something with them. The reason that I'm showing you these components is because I want to show you that there are a lot of moving parts. There is etcd, there is API server, there is kube proxy, there is the Kubernetes dashboard, a lot of components. And each one of them needs to be configured correctly. Each one of them has a lot of options. You can set up kubelets with no authorization, which I will show you. Each one of you that you have a laptop, right now you have kubelet configured without authorization. And I will show you how to leverage that. Or you can set up a lot of security with TLS authentication and IP-based firewalling. So you can do a lot of security, but you just need to know how to do that. So there is one thing that can help you about how to configure Kubernetes securely. This is the Center of Internet Security, the CIS. Who here knows what CIS is? Well, not a lot of people. So look it up in Google. They have standards for many things, security standards. How do you configure your Linux box? How to configure Apache? How to configure Windows box? And also one of those standards is a configuration of Kubernetes. It's basically a PDF document of about 100 pages, and it has a lot of checks. They tell you, please do this check, and if you get a specific output of this check, you need to fix it by doing that. So it's a lot of checks to do, and a lot of configurations that tells you how to make your Kubernetes more secure. The challenge with following a CIS is that you will need to do those checks manually. So basically, you will need to follow a PDF of 100 pages that tells you how to configure Kubernetes, which is tedious. You know, it's tedious when you have multiple clusters, when you upgrade, and for that purpose, what you can use one of the tools that are out there, an open source tool called kube-bench. Is someone here familiar with kube-bench? One person. Two. Okay, so we have two. So basically, what is kube-bench? Kube-bench is something based, it's an open source project in Golang, written in Golang. It has something like 1,200 stars, so it's quite popular. And what it allows you to do, it allows you to run kube-bench inside of your cluster. Kube-bench will check all of the CIS checks, those 100 pages of checks, and it will tell you what are the things that failed and what are the things that passed. This is an example of how kube-bench output looks like. So you can see there is check number 1.1.1. It tells you that your cluster currently failed for the check allowed privilege. So it means that it allows privilege containers. And there are a lot of checks, right? So basically what kube-bench will help you to do, it will help you understand whether you configured your cluster for the maximum security. It's not to say that you need to do that. You know, at the end of the day, it depends on your needs. So our first hands-on experience is going to be with kube-bench. I'm going to show you how you can test your Minikube in that case, but it can also be EKS, AKS, DKS, whatever Kubernetes flavor you have, and how to look at the results of kube-bench. Make sense? Yeah. Questions before I start? So let's move to the dark side of the moon. Let me open another. No. So first of all, what I will show you, I will go to the kube-bench project. So this is the URL. Oh, you don't see it. Sorry. Exit. So this is the GitHub project of that I just mentioned, the kube security under my GitHub account. And in the GitHub project, you can see that there are sections. One of the sections is talking about kube-bench. Right? So I want to show you how kube-bench works. I can click here on the link. It will take me to the kube-bench project. So this is the kube-bench project. Wow, 1,600 stars. Like it's getting popular, the kube-bench. The owner, the main contributor of kube-bench is Liz Rice. If you're familiar with Liz, she has a lot of work done in the open source community. She's also one of the CNCF chairmen. And as you can see, it's written in Go. Behind the scenes, kube-bench is running a lot of checks. Let me just show you where are those checks. You see there is a CFG directory. Inside of the CFG directory, there are the versions of the Kubernetes CIS. There were multiple versions, depends on the Kubernetes version. And let's just look at the latest one. You see, it's based on YAML files, so the checks themselves are declarative, they are specified in YAML file. There are checks for the Kubernetes master and check for the Kubernetes nodes, different checks based on the CIS. And each check looks like that. So there is a check number, for example, 2.1, you see. There is the description of the check. In this case, ensure that the anonymous auth argument is set to false. It means that in this case, kubelet will not allow anonymous authentication. And you can see that the way that the check is done is using shell script. It simply runs ps-fc, and it looks for the kubelet binary name, and it expects the output of it not to be equal, you see equal false, not to be equal to this anonymous minus auth. So basically, you will see a huge script here, this YAML file, of checks, commands that are running, and what is the expected result. That's all what kube-bench is doing, running commands, passing the output, showing you whether it passed or failed. Make sense? Okay, so let's run kube-bench. What I've prepared for you, there are different options to run kube-bench. You can read the project, what are the different options. What I'm going to show you is how to run kube-bench as a pod. So I can run a pod in the cluster that will actually check the cluster itself. There are also other options. So let me show you. Let me clone this project into my Git clone. And you could do it yourself. I'm just cloning the project I've prepared. And now I will enter the directory. Do you see it okay? And so I just cloned the project into my laptop. You can see that there is a YAML file called kubench.yaml. Let me just show you what's inside. It's quite a long YAML, but basically what it does, it will run a job. You see, it will run a pod of type job. And this job will run as something that has access to the host, because kube-bench checks the host. And it has a lot of mounts that it needs in order to run properly. And basically, it will run an image called kube-bench, an image that has the open source project inside of it. Okay, let's run it. Let's run kube-bench on my machine. So I will do kubectl, and you can also do it yourself. Apply -f kube-bench. So I just ran the job. Now I can do kubectl get pods. You see, this is kube-bench. It's still running. Now it's not running anymore because it's done. And let's look at the output of it. kubectl loads and the name of the pod that was running. And this is the output of kube-bench. I will go to the top. So this is a Minikube installed on my computer. Let's see what kube-bench found. So you can see that this test failed, 2.1.1. It means that right now, my kubelet, you see this is a test of kubelet, is running without the allow privileged argument. It's also running with the anonymous authentication set to false. And it's running with authorization mode set to always allow. What these three flags means, it basically means that anyone can connect to kubelet. So the kubelet has a REST interface, REST API. And basically what it means that I can connect to my kubelet and I can query it, I can tell kubelet please run pods, I can do everything. So this is right now completely insecure. And I will show you in a few minutes another tool that is going to leverage that insecurity. And this is the default. I just installed kubelet, right? I didn't do anything by myself. This is the default that you get. So one of my hobbies is to take kube-bench and to run it on different Kubernetes deployments. You check what's the output, and based on that, you know what you can do with that environment without authentication. Any questions? Yes?
Just a small one. I get, when I run into my Minikube, that I have an invalid object.
An invalid object? No. No. But I can check with you afterwards.
Yeah, sure.
Maybe one more thing to note. kube-bench itself, if we go again to the kube-bench, remember I told you that because it's a community-driven project, a lot of people are contributing those new YAMLs. So kube-bench can also check OpenShift, if anyone here is using OpenShift, or other variations of Kubernetes, right? So it's not just a vanilla Kubernetes, so you can see this is something we got from the community. OpenShift 3.10. People just, wrote their best practices. This is not CIS, because there is no CIS for OpenShift yet, but people contributed YAML files that will check Kubernetes. And what you can do in order to leverage those configurations, you just run kube-bench with a parameter of the YAML file. In this case, kube-bench will check all of the checks that are inside of those YAMLs. So what I'm saying is that you can write your own checks. You don't need to follow the CIS, you can extend that. Okay? Are we all good? Okay. Let's continue to the next one. And tell me if you need more time, if someone is running the kube-bench and you need more time.
It runs the dashboard.
No? What you can also try, go to the kube-bench project, clone it, and just run it.
Yeah, it's strange when I launch it through
the container it did not work.
Dashboard, the Minikube dashboard.
Creating.
Container creating now.
Okay. Good. So now that you know that you have Minikube installed, and Minikube, as I've shown you, has some weak defaults, weak security defaults. Of course, Minikube is not something that you will work in production, so it's probably okay. But let's see how I can leverage that as an attacker. And for that, I want to present you with another open source project called kube-hunter. Who here is using kube-hunter?
I've used it.
Used it, okay. Nice. So what is kube-hunter? Kube-hunter is an open source project that basically tries to attack. It does a penetration testing on your Kubernetes environment. It has about 75 different techniques to try and penetrate your Kubernetes environment. So it will try checking whether your kubelets are configured correctly, and if not, it will try getting into your cluster from the kubelets. It will try checking whether your role-based access control is set up, and if not, it will do something from that. And there is also some CVEs, some vulnerabilities that it will try to exploit. Now, it's not doing anything harmful, so it will not touch your cluster, but basically what it does like pings. It will try to verify a weak configuration. If it finds that, then it will try to do something. And usually this something will be just showing you data, showing you, hey, I was there. Look, I have proof that I was inside of your cluster. And that's it. It will not change the state of your cluster. So it's perfectly safe to try in production environments. Please do not try that on other people's clusters. This is not any tool for attacking clusters. It's only for your own penetration testing of your own clusters, similar to other penetration testing tools. For kube-hunter, there is also a nice web. There is a command line tool that I will show you right now. And there is also a nice web interface if you want to see the results of kube-hunter in the UI. It's under kube-hunter.com. So let me show you the command line. Basically, the command line is similar to kube-bench. It will tell you those are the results that we found, those are the clusters that we discovered, and those are the things that we were able to do. So as an example, I'm just showing you how HTML works. As an example, you can see that in this case, kube-hunter was able to do remote code execution because in this case, the API server, you see the master node, wasn't configured with authentication, so kube-hunter was able to connect to the master node and to leverage and to run code basically on the master node. Let me show you how it works. So for kube-hunter itself, okay, this is kube-hunter. You see there is a link to the project. Let me show you the project in real quick. kube-hunter, it's written in Python. So if you are a Python programmer and you want to contribute new capabilities into kube-hunter, feel free to do that. Like I said, it has something like 75 tests. All of the tests are written here. See, hunting?
We're not seeing.
We're not seeing. Oh. I need to stop sharing. Hunting. So you see under kube-hunter SRC modules hunting, so the way it works, for each Kubernetes component, like etcd, API server, the dashboard, there are attacks that kube-hunter tries. Let's see an example. So for example, etcd, you can see that kube-hunter will try to access this URL in etcd, and it will try to see if there is a response. And if there is a response, kube-hunter will identify, okay, it means that this port is open, I can attack, and therefore you are vulnerable. And there are many attacks for each component. Okay? Do you want to try it out? Let's try it out. So, in order to try it out, the easiest way is simply to run kube-hunter in your environment. kube-hunter is basically a utility. You can run it on your laptop. It also comes packaged as a Docker image. So, I'm going just to run it here.
It's a bit slow down.
What?
It's a bit slow downloading.
Yeah. So, in the meanwhile, I will show you how it looks like. I'm running kube-hunter as a Docker image. You see, it will ask me for question. Do you have a specific IP address of a Kubernetes cluster that you want to check? This is option number 1. Option number 2, do you want kube-hunter to do discovery on your network devices? If you are familiar with Nmap is port scanning. So basically, kube-hunter will use a similar approach. It will scan the network, and it will find kubelet, it will find etc. It will find them. So this is option number 3. This is option number 2. Option number 3, if you have a specific IP address, then you just give us the IP address. Let's do option number 3, because I don't know, maybe there is a Kubernetes here, maybe there isn't. I will let the kube-hunter find. And what's happening, kube-hunter now is doing port scanning on my laptop. Because I have a Minikube, you can see that there are some results. kube-hunter is finding things. And remember that I showed you that from a kube-bench perspective, the configuration wasn't ideal. So the configuration of my Kubernetes on my laptop had some issues. There were some tests that failed. And this is a good example of why having a secured by default approach is something so important, because if you have a bad configuration, you will not be able to hide. Someone will find it. And this is an example. So kube-hunter, let's see what kube-hunter just found. You see, oh, it found a lot of things. So many things. Okay, let's start. So it was able to identify that this address, by the port number, I can tell you that this is kubelet. Kubelet is something that runs on the node. It was able to do remote code execution. Basically, you see, it was able to run this command, union-a, on one of the ports. Now, why is it important? You saw how I ran kube-hunter. I didn't give him any credentials. I didn't give him anything, right? It's just an application that will connect to my environment over network. And nevertheless, it was able to connect to pods and to run union-a. I'm going to show you how we did that using curl in a few minutes. Let's see another example. Here, you can see that it was able to identify the Kubernetes version. It was able to identify how many pods I have running. And again, no credentials were provided, which is quite nice. It was able to identify what is the status of my health check. You see, it knows that my Kubernetes is running. It knows how many pods there are running. Overall, 43. Some of them are not running. And so on. Even it was able to identify what are the etcd, you see, the logs. It's not etcd, so those are logs of some of the containers. So it shows me an example of logs of one of the pods, of the etc pod. Now, the nice thing about this example is that in order to do that, kube-hunter basically did a lot of tries and errors. It tried to connect to something. It wasn't able to do that. It tried another thing and another thing. So as we add more tests and more capabilities, more hunters, it will cover more vulnerabilities and more configuration issues. Right now there are, like I said, 75. Let me show you how it basically works, or how an attacker can basically leverage some of the things that I've just shown. So let's say that I have kubectl get pods. On my environment, you see that I have an Nginx running. Just an innocent Nginx running on inside of my cluster. And I want to show you how dangerous it is that you have those issues inside of your Kubernetes. So let's do that. Let's do kubectl exec -it, the name of the pod, bench. So I just exec into one of the pods in the cluster, right? And think about the situation. You could be running pods that you got from someone. They don't have any capabilities. Those are not privileged pods, nothing. It's a regular pod, a regular Nginx pod. Now, because my Kubernetes setup is not configured correctly, I want to show you what a pod that is running inside of Kubernetes can do. I have this already prepared it. Okay. So, you see this command, curl, curl. This is the address of kubelet, IP address, and I can get this address by doing nmap from inside the pod. So I can scan the network, I will find kubelets inside the network. And what I'm doing, I'm going to the /pods URL. JQ is just to make it nice, so that the JSON output will look nice. So you can see I just ran a command against kubelet and I got all of the running pods in my environment. So think about an attacker, someone that was able to get inside of your network, either by you guys running an image that you don't trust, an image from some public registry, or by being able to run some code inside of your network. Without any problem, I can simply read all of the pods. I can see all of their arguments, including secrets. Right? If you have environment variables that have secrets, I will see them. And I got so much information. I can do basically everything, just because that I have a running pod inside of your environment, and because that you did not configure Kubernetes the right way. You have your kubelets done without any authentication. Okay? The second thing I can do, let me show you this one. I can do CURL. You see this address? This is the API server. This is the Kubernetes cluster itself, right? The API server. If I would try running this command, I'm trying to connect to the API server, and I'm trying to look at the pods, not only at the kubelet level, but also at the API server level. Do you know what it means? It means that if I'm connecting to the API server, the API server will tell me what are the pods running over my entire cluster. This is different than what kubelet will tell me. Kubelet will tell me only about the pods running on a single machine. So now I want to do another type of check. I want to check the entire cluster. But you can see that what happened, this is actually nice. I'm getting access denied. You see? Why is that? Because Minikube, what they did secure their API server. So the default installation of Minikube doesn't run with anonymous authentication for the API server. It only runs with anonymous authentication for the kubelet. So I wasn't able to list any pods at the API levels, right? But what I can do, and let me show you that. So let me explain what is this command. I'm doing the same thing. I'm doing CURL. -K means that it's an insecure connection. So I trust the HTTPS certificate. And I'm passing an authorization header. Now, in the authorization header, I'm passing the contents of var, run, secrets, Kubernetes, token. You see? You know what is this file? When you run a pod, every pod that runs has a service account associated with it. Every pod. When I'm running a regular pod, a default pod, it got access to the default service account. Now, if you do not configure Kubernetes with role-based access control, which the default, in my case, I will show you in a second, is that it is not configured, then everyone with access to the service account can query the API server and can also start pods, stop pods. I can do everything. So let me show you. Oh, you see, now I got all of the pods, now not only from the kubelet, but now I was able to get all of the pods from the API server. So again, I want to keep in mind this very important parameter. Maybe I will also show you how it looks like. See, there is a file inside of every pod. It's a file that Kubernetes automatically creates inside of your containers. It's under var, run, secrets, Kubernetes, service account, token. And this file is basically your token. This is the token that is used for authenticating against the API server. And by default, you are getting the default service account, which by default has a lot of access. I can do everything. Make sense? Any questions? Don't try it at home, okay? Do me a favor. Those are dangerous things. If you don't know what you're doing, so don't try it. The good thing is that it can be easily solved using configuration. So if I will go up, let's see if I have the history. No, I don't. But if I will show you kube-bench again, you will see that one of the kube-bench tests was about the kubelet configuration. So it would show you that kubelet is not configured, okay? But another test will be about the API server configuration. And in that case, it would have told you that your API server is not configured with role-based access control, and you need to enforce role-based access control. Otherwise, you see, it's a disaster. It's very bad. It means that every pod can do a lot of damage in your environment. Okay. Let's move on. Anyone is trying that? Anyone is trying kube-hunter?
Yeah.
Yeah? Did you find something?
Loads.
Loads?
My test machine.
It's on your test machine. If you also have access to your production cluster, I do encourage you to try it. Most times it will find things. And even if it will not find things, it doesn't mean that they are not there. It's just those 75 tests that we have right now. Okay, let's move on. I think I talked about it. You will see it in the slides that I wanted to show you that there is a correlation between a kube-hunter test. You see, in this case, this is a test that we were able to penetrate to a machine, and because of the kube-bench configuration. So at the end of the day, it's very easy. Just configure your Kubernetes correctly. Good. So let's now move to the last part of the session, the scanning, microscanner. So before I dive into the tool, I want to give you some background about vulnerabilities. I think there is a lot of education right now needed in the markets. People are talking about vulnerabilities like it's the worst thing on earth. Vulnerabilities are an issue, but you need to understand them in order to understand whether there is an impact or not on your environment. Because not all of the vulnerabilities are equal, right? So I will use this opportunity for some education around the area. So first of all, who here knows what is a CVE, what is a vulnerability, the concepts of vulnerabilities? Okay, most of you. So I will just say in a few words, every software has vulnerabilities. What is a vulnerability? It's basically a bug. A developer forgot to handle some edge case, some use case. A developer did not put input sanitation, and it allowed an unexpected behavior that can be leveraged by an attacker. So for example, let's say that you have a web page, and your web page will show, I don't know, phone number of a person. So your web page will have an input of the person name and an output of the phone number, right? A very simple application. But if the developer did not use SQL sanitation, then an attacker, instead of providing the name of the user, the name of the person to look up the phone number, an attacker can put something like semicolon or drop table contacts. It's very simple SQL injection, and that's a vulnerability because a developer did not, handled one of the cases of input sanitation. Right? So at the end of the day, it's a human error vulnerabilities. It's because of human errors, and the way to fix them is to fix the code. You need to go into your code and fix the logic. Basically, it's simple. It's not that hard. Now, how do you know about vulnerabilities? Basically, there is something called NVD, the National Vulnerability Database. Every time there is a vulnerability, the vendor, the owner of the application, will report that vulnerability, and you can look the vulnerability up in the database. Usually it will have a very strange name, CVE-year-number, okay? So NVD has all of the vulnerabilities, huge percentage of vulnerabilities. Now, another thing you need to know, whenever there is a vulnerability inside of a package, let's say CURL has a vulnerability, it will be published on NVD. It will get some kind of a severity, low, medium, high. And this vulnerability will be regardless of where the package is used. So for example, I'm using an iPhone. Let's say that there is a vulnerability in a library in the, I don't know, lib OpenSSL or something like that. So the same vulnerability is in a package used inside of my iPhone, inside of an Android, and also on a Mac. Now, when this information is disclosed inside of the vulnerability database in NVD, they don't really know what's the context, so they don't know where the package is used. Nevertheless, they give the vulnerability the same severity and the same score, right? So when you go to NVD, you will see a generic information about the vulnerability and its impact. But the scoring is a little bit of a challenge. On the other end, there are the vendors themselves. Debian, Red Hat, CentOS, not CentOS, sorry, Ubuntu. They all have security advisories. And usually what happens is that whenever there is a vulnerability in one of the packages, like I said, OpenSSL, then the vendor itself, in this case it might be Red Hat or Debian, will also publish their view of the vulnerability. Sometimes they can say that the vulnerability does not affect them. On other times they can say that they already fixed the vulnerability because they did a backport of the fix into older versions. So there are many cases where you will see deviations. So NVD will say one thing, and the security advisor of the vendor will say another thing. Make sense? A question?
Did you already patch your Perl by any chance? Because it was actually a CVE yesterday.
Of
Because
Perl?
you were just using it.
Ah, I didn't know. Okay. Yeah, there are new vulnerabilities every day. I think the number is like, I don't remember if it's in the hundreds. I don't remember the exact number every day. And there are RSS feeds, and you need to keep your system patched. So that's most important. Now, let's talk a little bit. Where am I? Here. Let's talk a little bit about vulnerabilities in Kubernetes, or most importantly, in images. So what is an image? An image is basically a composition of an operating system. So I can have an Alpine image, a CentOS image, a Debian image. I'm taking an operating system. On top of the operating system, usually you will add some kind of an application, Nginx, Apache, Tomcat, some packages of an application. And you will have application files, like source files, NPMs, JavaScript, and you will have configuration. All of that mesh is what is called an image, right? A lot of times, you would be asked by your organization where you're working or because of, you're just security aware, to check what are the vulnerabilities of your image. Why is it important? I just show you that, if there are problems like in Kubernetes that was not configured correctly, someone will be able to leverage that. The same applies for vulnerabilities. If you have a Tomcat image or some kind of an application image running inside of Kubernetes and it has vulnerabilities, an attacker will be able to leverage that and to do either exfiltration, lateral movement. There are many techniques that an attacker can leverage. So it's very important to identify those vulnerabilities and to check whether you're vulnerable or not. When talking about vulnerabilities for images, you need to check whether the operating system that you are using is vulnerable or not, whether there are known vulnerabilities for the operating system. It's also important to check whether there are vulnerabilities to the applications running on that operating system, to the packages like Node.js, so like NPMs, JavaScript, libraries, things like that, and to binaries. You guys can download the binary and do untart to the binary and just put it inside of an image. So this is usually the scope when talking about vulnerabilities inside of images, and there are different ways to scan those images and to tell you whether they are vulnerable or not. Any questions before I move on? whenever you do a scan of a vulnerability, the solution that you are using for scanning, and I'm going to show you something called microscanner, it's a free vulnerability scanner for images. The solution can check the vulnerability against NVD, and like I said, NVD is some generic database of vulnerabilities, or against the security advisory of the specific operating system, against Red Hat, Debian, etc. Microscanner, that we are all going to use in a few seconds, it uses the vulnerability from the advisory. So it will, if you have an image which is Red Hat, microscanner will connect to Red Hat and check whether the package that you are using is vulnerable or not. Right? It will not use NVD. Maybe I have two examples showing you why is it important. On Debian reported a vulnerability, and this is the number of it, 2 years ago. On the right side, you can see this is what NVD said about the vulnerability. NVD said that basically everything between version 4 to 5.2 of this varnished HTTP cache is vulnerable. But in reality, what happened, Debian, you see this is Debian, a security advisory, Debian actually fixed a lot of the version. Why is that? They backported. They saw that a fix was available in the upstream. They took only the fix and they backported it to many versions. So actually in that case, NVD was wrong. NVD said everything is vulnerable, but the vendor fixed it. There is no vulnerability for Debian specific version. The same goes for Alpine. You can see NVD. NVD complained about a lot of vulnerabilities, especially in busybox 127.2. But the reality is that this is busybox 127.2, and I'm showing you those are the commits done inside of the repo. It was fixed. It was backported and fixed, right? Because at the end of the day, like I said, the NVD will tell you in a generic way. They don't know what each vendor is doing. They will tell you it's vulnerable, but a specific vendor might choose to fix it. Okay, let's now talk about microscanner. So what is microscanner? Microscanner, like the name implies, it's a vulnerability scanner. It's a micro one, meaning it's a small one, that will scan for vulnerabilities. It will check your image for vulnerabilities. The way it does that, and this is an example, a snapshot of microscanner, you add microscanner into your Docker build. Anyone knows what a Docker file is?
Yeah.
So Docker files it's a file that tells Docker how to build an image. So this is an example here. You see, this is a snapshot of a Docker file. It says from Debian, meaning the image will be based on the Debian J.H.A operating system. There is, after that, few lines. And basically, you see those 1, 2, 3, 4, 5 lines underneath the from Debian. Those are the lines that you need to add in order for microscanner to scan your image. So in this case, what will happen, microscanner will scan Debian J.H.A. It basically will, let's go one by one. It will update an image and install the certificates because it needs HTTPS access. And then it will download a binary that it gets from acrosec.com/microscanner. It's a full binary. It will chmod, it will make it as an executable, and then it will simply run microscanner with a token. Make sense? Simple? Now when you will do the command docker build, and this is your Docker file, what will happen, Docker build system will run all of those commands one by one. The last command will cause microscanner to run inside of as part of your build system. And microscanner, which I will show you in a minute, it will scan the image. It will check all of the packages inside of your image. It will compare them against, in this case, it will compare them against Debian, and it will tell you whether they are vulnerable or not.
Not already when you add via HTTP request and
This one?
in the end you have no way to verify that the binary import.
Yeah, so usually that's just a demo. Usually what I would suggest you, don't download it from the internet blindly. Put it somewhere inside of your organization with, verify the MD5 signature. It's written inside of the Github repository. What's the MD5? Put it inside of your organization and use it from there. Don't blindly download every time you do a build from the internet. That's not a good practice. But basically, yeah, you need the binary to be inside of the image. So let's see how it works together, and you can try it with me. It's very simple to run this micro scanner. Let's see. So on the page, you have here a link to the microscanner project in Github. In order to use microscanner, you need to provide what is called a scan token. The reason there is a scan token, remember microscanner is free. We didn't want people to abuse it, like Amazon, like let's say a huge company will use microscanner to scan all of its infrastructure, and it will add some impact on our service. So there is a limit of, I don't remember, maybe 1,000 scans per month. I don't remember what's the limit, but basically you needed something called a scan token in order to do a scan. In all of the cases, we never came to a scenario where this limit was not enough. It's usually enough, and it's it's fair. You use it for free. You improve your open source project, and you don't need to pay. That's the outcome of that. So in order to do that, what you need to do first time, let me show you really quick. You need to run this command to register. So you do docker run --rm. You run the microscanner with a ---- register flag, and you give it your email address. Sorry. I will do it again. And what will happen is that you should get an email with your scan token. And in order to run microscanner, you need a scan token. Right? It's free, but still you need a scan token. It usually takes a second. So the next step is now to add microscanner into a Docker file. So if you cloned the project that I've prepared, this project, the Kube Security, there is already a sample Docker file in that project. Let's look at the Docker file. Basically, what this Docker file does, it will take Alpine 3.6, and it will add microscanner into Alpine 3.6. You see all of those commands. It basically adds the certificate, and then adds the microscanner binary, and then runs microscanner. Okay, so let's do that. Microscanner. So I'm just running Docker build. I'm giving it the build argument, and I'm providing the token that I've already took for my email. You can see that the steps are running. Step number 1 from Alpine, and then step number 6, now microscanner binary is being downloaded from the internet into my image. I need no cache, sorry. No cache. Yeah, one of the things with Docker, because the layers are cached, if it already ran it one time, so it will not run it again, the same image. It's caching the commands, and if it sees that there is no difference between the last time I ran it to this time, it will not actually run anything. Okay, so I'm running it again.
But you would also be just able to run this in a virtual machine.
What do you mean? What is a virtual machine?
Just a VM, not a container, but like a whole VM.
Ah, you can, yeah. You can hack it, yeah. You can. It will still work, it's the same. Because what it basically does, it goes to the root file system and scans it. So it doesn't know that it is inside of an image. So let's look at the scan results. The scan results, it's a JSON file. You see that it tells me that it found total of 2 vulnerabilities. Basically, this is the official Alpine 3.6 that you can find these days on Docker Hub. It found 2 medium, so it didn't find any high severity vulnerability. Let's look at the vulnerabilities themselves. If I go up, it will tell you this is the vulnerability. You see something from 4 years ago. And in this case, it's because of the use of busybox 127.2. And there is a vulnerability that was not fixed in that case. Something that busybox decided not to fix. And another one because in that case, busybox before 130. You see again, a vulnerability that was not fixed. Okay, very simple. There is also a link to information about the vulnerability itself. So in this case, it's a link from NVD because NVD has a very good description about the vulnerabilities. And the score of the vulnerability, in this case, the vulnerability score is 5. Okay, which is nice. Now, let's do a small check. So Alpine doesn't have a lot of vulnerabilities, only 2 vulnerabilities. Let's do the same thing on an image with more vulnerabilities. So I've prepared ahead of time something that can show you more data. Here. Microscanner. So there is another option to run microscanner. See, this is microscanner, and this was something contributed from the community. There is something called microscanner wrapper, because sometimes you don't want to put, a piece of code inside of your images. Sometimes you already have an image, you just want to scan it from the outside, right? So someone from the community contributed this code. It's not someone from here, right? Okay. And what does this microscanner wrapper does? It allows you to scan an image from the outside. So it's basically a shell script that does that. It does the automation of Docker build, and you can look at the shell script what it does. It's quite simple. It's not a lot of lines of code. So let's do that. Let's try to run a scan on an image that I'm not building. A scan on an image that I already have on my laptop. So to do that, I will clone this project. I will copy it. Git clone this guy. I will go to the micro scanner wrapper directory. And basically, you can see the usage. It's documented here. You have an environment variable called microscanner token, where you put the scan token. And then you simply run scan.sh and the name of the Docker image. If you don't want to download the Docker image, if it exists locally, so there is also another option with another environment variable called use local. In this case, it will scan only the local image without downloading it from the register. So let's run that. Okay. So I'm putting use local equal 1. I have my microscanner token. I'm running scan.sh on an image called Jerbi demo. My image. I have it on Docker Hub. So you see, behind the scenes, it creates an image that is from the image I want to scan. It adds microscanner into it, and basically runs Docker build. So that's all it does.
How does microscanner work? Do you compare hashes from binaries in the files? Or?
So the way it works, yes, it's a good question. It will take all of the packages that you have installed, either on your machine or on your image, and it will send them. That's why you need a scan token. It will send them to something called Cyber Center. It's a SaaS service. In the Cyber Center, we have like terabytes of data of vulnerabilities, like from 20 years ago, and it will compare the name of the packages and hashes against what Cyber Center has. If it finds a match, it will tell you, hey, this package is vulnerable. If it doesn't find a match, it will simply ignore.
If package is compiled from is backported, then the name of a file would be the same, but the hash would be different. So it would.
Microscanner only supports official packages. So if you backport by yourself, nobody knows about it.
Of course, it will work. But if the package from the repository is backported, then it will be in your repository and will give a result.
So usually, every time that a vendor does a backport, it will give a different number. So look at that, for example. See Debian, when they backport, can you see it's too small. When they backport something, then although it's still version 5.0, they will add, you see this? 5.0, they will add something at the end of it. So when microscanner checks for vulnerabilities, it will take the entire string of version, and it will compare it against what the vendor said. So if there is a match, it will know that, okay, it's fixed. If there is no match, it will tell, okay, this is vulnerable. So there is logic there that knows how to do that. Okay, so I just ran microscanner on Jerbi demo. Please do not run Jerbi demo on your machine. You can do some damage stuff to your machine. I just want to scan vulnerabilities. You can see that in case of Jerbi demo, there are 53 vulnerabilities. 16 of them are of high severity. And you can go up and see a lot of the vulnerabilities there. Let's see this one, for example. You see this is a vulnerability in a package called wget. Now you can see, to your question, you can see that the solution for this vulnerability is to upgrade to this specific version. You see, 1.16. something. And this is something that only the vendor knows. So only Debian knows how to, fix a vulnerability. NVD will not know about that. So what I suggest, did anyone here ran this microscanner on your images? That one? Okay, it's too complicated. What I suggest, just use it, scan your images, see if you have vulnerabilities. Usually, it's not easy to fix vulnerabilities. I can tell you that. It requires a lot of changes, and sometimes when you change one package, then there are dependencies. So you will need to change also the dependencies. And at the end of the day, it's something that you will need to continuously run. You will need to check the vulnerabilities on every bit. Okay. If you want any reference, so you have all of the information about the Github project, and also on the project that I've prepared, this one, you can see that there is a file called presentation.pdf. So the presentation that we've just seen, it's also there. You can take it and use it by yourself, do yourself a meetup and talk about those issues. Okay, any questions before we finish the workshop? One question?
We're running the microscanner.
Yeah.
But just with the VM, I'm just curious what would happen.
What a VM?
Taking up a lot of resources. What's the explanation?
So what it does, the microscanner, it will go over all of the files in the file system, and it will create this very big JSON. So it depends how big is your operating system. You know, images are usually small, but if you have a 50 gigabyte or so basically it will go over everything there. It will create very big JSON, and at the end of it, it will send it for examination. This big JSON. It can take minutes.
Well,
More than minutes?
15 minutes now.
15?
Yeah, 10.
No, 50, no. 50, 50?
No?
15.
15.
10 to 15 minutes.
How big is your...
Yeah, well, it's just a VM, so what is it, like 20 or 30 gigs?
30 gigs.
Ah.
Yeah. It's a little bit too much, I think, yeah.
But looking at each individual file, not just at the RPM level. Okay,
It looks at RPM level. No, only RPM level. Yeah. It shouldn't take that much. Yeah. Only, what is the operating system that you have there?
Ubuntu.
Ubuntu.
Ubuntu 18.
Maybe I'm wrong. I think it only takes the RPM, the package manager level.
Oh, that's found some interesting data that it wanted to set up.
No, I'm wrong. It's not only I'm wrong, yeah, it's my mistake. It also takes hashes of binaries.
Yeah.
Hashes of binaries. Yeah.
Anything that's executable or something.
Anything that's executable that wasn't installed through a package manager. But it will send only the hash of that, otherwise it will kill us.
But the reason it's using all the resources is because it's hashing all the
files, yeah. So if you have a file of 100 megabytes or upload, it hashes it. Yeah. So you will see some I/O and CPU.
Yeah, also CPU.
Yeah. Usually, what you can do, you can give it less CPU.
Yeah, you
Use
can
less.
it. Yeah.
And when I'm running it on my builds, I use C group, so I limit the amount of CPU consumption.
How difficult is it to capture secrets in kubectl?
To capture secrets?
Yeah.
In kubectl?
Yeah.
It's very easy. What do you mean how difficult? Because usually depends on what secret solution you're using, right? If you're just passing secrets as environment variables, then when I do the command of...
between pods I need.
Between pods?
Between the cube database and the pods,
for
example.
Between the cube, between etcd and the pods?
Yeah.
No, so the channel there is encrypted.
Yeah.
There are ways to do that as well. I'm not going to talk about that when the camera is on. But basically the channel is encrypted, so the way that secrets are transferred to pods is there is an encrypted channel to etcd. So theoretically you cannot do it to eavesdrop that channel.
By default, is it enabled?
By default, yeah, it is secure, yes.
If the secret is stored copied somewhere in the container itself, you should be able to unencrypt it. You should be able to read it.
Easily, yeah.
If you can.
Easily. You just go to /proc, / the PID of the process, usually 1, /environ, do cat, CAT, to this path, /proc. If you are on the host, right? /proc, the PID of the process, /environ, and you see the secret. It's there. So even if everything is encrypted, it's very easy to look at secrets.
With your database for the scanner, use consider if only if it is a CVE, or does it consider something specific use applied to containers? Some CVEs are not applicable when they were in a container or
so in microscanner, we'll only do, it doesn't know the context of containers, so it will show you all of the matches. Let's leave it like that. Yeah. Yeah, it's not, but actually it's not true. There are a lot of vulnerabilities that are unrelated to containers. So for example, I can give you, let's say there is a vulnerability in DHCP. Do you know what's DHCP? It's a protocol to assign IP addresses. It has nothing to do with containers. They are not using it. Nevertheless, you can get a scanner to tell you that there is a vulnerability in DHCP. And you need to know that, okay, it's not irrelevant, let me remove that. But the microscanner will not know that. It will tell you there is a vulnerability. Yeah, but we also need to leave room for commercial products on top of the free. So a commercial product will know that. Yeah.
For how long is the token valid?
How?
For how long is this token valid? Can you use it like all the time?
Yeah, it's forever, free. There is a limit, a fair use limit. Like, if you're going to scan the entire Docker hub, you will be stopped after, I think it's 1,000 scans. In the page, let's quickly check. I think there is something about the fair use limit. Let's see. Microscanner, you see this is the page. And I will look for the limit. Your token will be rate limited. Okay, so we just reduce you with the time. It will take more time. But please don't use more than, leave room for others to scan as well.
It's done now.
It's done?
Yeah.
19 minutes, maybe 20.
Yeah, something like that.
So it's about a minute per gigabyte.
On my VM, the total was 312 vulnerabilities.
Okay.
To be fair,
It's a lot.
are negligible.
Negligible means the doesn't
No,
work.
and the over 100 are low.
And how many high severity?
2.
Ah, so you're good. What version of Ubuntu?
18.4.
Ah. So you're missing a small upgrade and you're there.
Yeah, I think so. I'm doing that now.
It might be the curl updated yesterday.
Yeah, probably.
Yeah, there's two, the curl and the curl.
Yes, sir. Check the too high severity.
It's too
long.
much. Yeah. I forgot to try
To
to
JQ.
Yeah.
Interesting. Okay, guys, good luck with the security hunting, kube-hunter, kube-bench, and the microscanner. Okay.
Maybe I missed it, but how did you get the intelligence of all the hashes you get? How do you translate that to vulnerabilities?
So what you need to do, you need to, first of all, have something called a tracker. Tracker is something that will connect to Debian, Ubuntu, all of the security drivers. And basically, they all have some kind of RSS feeds. So you need to consume that information and create this very, very big database of this. And the second thing you need to do is whenever you scan a VM or scan an image, you need to understand what is exactly the name of the package and its version of it. Because, every vendor has a different way to do that, and the way that is different with Debian. Once you know the version, you compare it against what the tracker is saying. So let's say you understand that this is KRC or version 5. The tracker is saying version 6 and below is vulnerable, then you do the match. So there is a lot of logic around that.
But do you have to do a lot of manual work on your side? In the database?
Not a lot. I would say 90% is automation, 10% is manual.
Because how do you do that? Do you like, so you have the RSS feeds you collect, and then do you have all the, do you clone all the repositories to create the hashes, or how does that work?
Yes, we clone all of the repositories to create hashes. We clone all of the RSS feeds. Not clone, we consume all of the RSS feeds. There are many cases where it's not indicative, so you don't really know the description there is not enough. Those are the 10% that are manual. You really need someone to read the description. It's a lot of work.
Yeah.
But at the end of the day, once you get it, it's like a machine. Over and over.
Okay. Very nice.
And the hashes are provided in the feed.
No, they create the hashes themselves.
We compare hashes. Yeah, we compare the hashes. Yeah, there are a lot of techniques. One of the techniques that we are also using, we are looking, I showed you commits, right? So we are looking at the commit messages. Let's say someone fixed the vulnerability. Now in the commit message, there is the fact that the vulnerability was fixed. So you need to parse all of the commit messages to understand that there is a fix, to correlate that to the released version, and then you know that this version has that fix. So there is a lot of magic, I would say.
And do you use this a lot for clients, or?
Compliance. Because at the end of the day, there are regulations that do not allow you to run with vulnerabilities. So when you get an audit, you need to show that, hey, I don't have any vulnerabilities. So, yeah. And not only compliance, this is actually security best practices. If your organization is running with vulnerabilities, someone will leverage it.
I mean, it's not compliance, but do you run this for your clients?
No. So usually they will run it for themselves. We provide them with the software.